Testing. Alright, that's a training course of 1998 Navy Electricity Electronic Training Series, Module 21 test methods and practices approved, distribution approved for public release. Chapter 3, Part 2. Calorimeters. Calorimeters are the most accurate instrument of measuring high power. The calorimeters depend on the complete conversion of the input electrical, mechanical engineering into heat. The direct heat required for the measurement of the heating effect with the medium load and terminating the line. Indirect heat required for the measurement of the heating effect of the medium of the body with the original power absorbing material. Power measurements are true calorimeters. Methods solely on the temperature of the mass and time, and substitution methods used are known low frequency power to produce the same physical effect with the unknown radio frequency power being measured. Calorimeters are classified as static, non-flow type, or circulating flow type. Static calorimeters are thermally with a shield body for the isolated with the body loss. It loses little heat to the surrounding medium of the temperature and keeps the body with the directional portion of the time of life with the power of the product rate of the temperature is in the calorimeter body, and its heat capacity equals the applied power. Figure 3.18 illustrates the static type calorimeters. I show the radio frequency, low frequency power to rheostats, isolated calorimeter body temperature. The most common type of the static calorimeter is the adiabatic calorimeter, with the adiabatic meter is powered directly with the thermally isolated body with a rate of temperature rather than determine the temperature change of the measure during a sufficient long known time interval. Figure 319 illustrates the adiabatic calorimeter using the water body with the covered or flask. A tapered wall at one end of the waveguide contains a sealed inclined glass portion to create a wedge-shaped water load of the low reflection coefficient. Through mixing the water, accomplish stir and sensitive thermometer measure for the temperature arrived. The heating coils are wound around the waveguide inside of the calorimeter with a calibrating principle of the low frequency power is applied. The type of the meter can be the accurate measurement of several hundred watts of average power and can withstand 50 kilowatts of peak power. So your adiabatic calorimeter with the thermometer, heating coil, thermos body, wave shape, water load, baffle, stir and baffle waveguide input. Adiabatic calorimeter uses radio frequency germination resistive film strip loosely with the dielectrical material. The solid liquid is designed efficiently to dissipate with the applied power as load. Temperature indication can be accomplished with the thermopile with the thermistor of the thermometer, the biomedical bimetallic strip with the manometers. The calibration is applied power during the low frequency power. Based on the average above the principle, the coaxial calorimeter is a good sense for the short 50 ohm resistive of the film of the lava, the dielectrical center conductor, and clove with the tape of the thin-walled outer conductor is used at the frequencies between 0 and 1.2 gigahertz. The radio frequency with the temperature termination is electrically connected to thermally isolated with the pump mounting plate with a short section of silver lava, the coaxial line with a high thermal resistance. Steady state with the temperature rises to outer casting with the load with respect to the mounting plate is measured with the differential platinum resistant thermometer with a Wheatstone bridge. Low frequency power with the termination provides method of calibration. Power is in the range of the 0.0 to 2.5 watts being measured. A 70-second time interval, constant steady temperature are attained in about 6 minutes. Small physical side of the termination to keep corrective and radiative heat loss low. Provides high sensitivity calibration, low frequency power with extremely accurate because of the termination broadband should exhibit the same power distribution of the DC 10 gigahertz. A twin calorimeter provided with the method of the UV. The new calorimeter would provide thermally shielded against the ambient temperature variation. Improve the sensitivity. Figure 320 illustrates the type of the calorimeter device. The power being measured applied with the calorimetric body. The other calorimetric body acts with the temperature reference for the state of the temperature difference between the two calorimeters. As the power measure radio frequency power calibration is performed in applying low frequency power with a differential air thermometer type of temperature difference indicator shown figure 321. Use the twin calorimeter with the dimension for the microwave power of the 0.1 milliwatts. The instrument consists of the two similar glass cells connected to the calibratory tube containing a liquid pellet with each glass cell contained with a tapered carbon-coated strip entire assembly mounted with a rectangular waveguide. The balance of the DC portion heats one strip, the other strip is heated by radio frequency power liquid pellet that will indicate the differential expansion of the air within the two cells is viewed for the aperture in the waveguide wall provided with a microscope microscopy, high sensitivity to produce the measurements with 2% accuracy with 10 milliwatts. Radio frequency, low frequency resistor, identical calibrator bodies, thermal pile, and other temperature difference measuring device, twin calibrator system. Show the wave liquid pellet, DC balancing power, metal plate with a carbon strip glass cell, the DC equivalent centimeter wave radiation flow calimeter. Flow calimeters are classified by the type of the circulating method, UV the open, clove the type of the heating, UV the direct, indirect, and the type of the measure for the perform of the true calimeter with a substitution wave of the weight, water or other calimetric fluid, usually only one for the open system. The overflow of the system, UV the maintain the constant rate of flow of the closed system, recirculate with the fluid continuously by means of the pump of the cooling system, or over the fluid with the ambient temperature prior to the return of the calimeter of the closed system are more elaborate and permit the use of fluids other than water. Flow calimeters provide the primary standard of the measurement of the high power level in the conjunction with the calibrated directional couplers, actuators, power dividers, and any similar device serve as a standard medium low power measuring instrument. The measurement time depends on the requirement time of the entire fluid at each of the outlet. When rising, the temperature is measured. The circulating fluid is measured for the dual capacity dissipated medium coolant. Using the direct heating method, the solely coolant using an indirect heating method because of the excellent thermal property of the high dielectrical loft of 1 gigahertz. High water is normally used. Both heating method of the water is rarely used. The fluid frequency is lower than 100 megahertz because of the insufficient dielectrical loft. The indirect heating method offers the wider frequency power range covered and can be used in substitution type measurements. The true calimeter measure the calorimeter measurement contains the appreciable error with the because of the uniformity of the flow rate, the air bubble, the flow rate measurement, the inaccuracy of the temperature arrived at the flow regulators, bubble trap. The good thermal insulation are required to eliminate the majority of these errors. Substitution method does not involve the direct heat of the dissipation measure for the moving liquid. Greater accuracy obtained because of the known low frequency power substitute with the unknown radio frequency power with all the measurements parameters remaining constant with the accuracy depends on the exactness of the flow rate frequency power determination of the degree of the factors remain fixed during the substitution of one type of power with another. Figure 322 illustrates the low calimeter view of the low frequency power substitution. Two different measurement techniques are possible. The type of the mean of the calibration technique and the balance technique. Calibration technique with the adjustable known power to exactly reproduce the same temperature indicating originally obtained with the unknown radio frequency power management. The balance technique initially low frequency power to provide steady state temperature rise in the calimeter fluid. The unknown radio frequency power is applied, but the original power is reduced to the new power to maintain the same temperature indication. Therefore, the actual power is original equals the original power plus the new power. Figure 323 illustrates the widely used method of power measurement with the balance flow calimeter, the temperature sensitivity resistive bridge connected with thermometric element from the balance at the ambient temperature prior to the application of the power low frequency balancing power and the unknown radio frequency applied with the maintain the bridge at null. The S curve of the limit temperature rises and caused by the unknown radio frequency power equal with the temperature rise caused by the known low frequency power. 322 show the flow of the calorimetric system. Either the substitution low frequency power flow regulator flow system, maybe even the open clove, the thermal pile, other temperature device, measuring device, radio frequency power calibrated low frequency power, the radio frequency resistor 1, 2, 3, 4, radio frequency power calibrated low frequency power, inlet temperature, outlet temperature, break connections, resistor 1, 2, 3, and 4. Frequency measurement. The frequency measurement is essential to prevent the correct maintenance for the communication electrical equipment. The rotation frequency of some of the mechanical devices must be determined. The output frequency of the electrical power generator is checked with the engine start during the preventive maintenance routine. The other operates for the auto frequency range, but must be attained with the operator with the correct frequency. The radio transmitter must actually be tuned with the assigned frequency to provide the reliable communication to avoid interfering with the radio circuits operating on other frequencies, and only a few applications make the frequency measurement. Frequency measurement methods. Frequency measurement equipment devices, particularly those of the determined radio frequencies, constitute of a distinct type of equipment because of the important critical nature of the measurement, the requirement of the precise calibration, extremely important with all the frequency measuring work. To provide accurate measurement every time the frequency measuring device must be calibrated against some of the frequency standards. Frequency standards are considered important for the measurement of the frequency wavelength with the standard of the gain of the frequency measuring device are compared with the calibrated. The frequency standard belong with the two general categories, primary and secondary standard. The primary frequency standard maintain U.S. National Bureau standard for long-term stability, accuracy of the 1 part, and then the 10 to the 12. Usually, the atomic clock with the secondary frequency that is high stability, but the accurate standard has been calibrated against the primary standard with the standard secondary standards maintained with the calibration laboratory service to be your test equipment. National Bureau standards provided at the time of the frequency of the station of the WWV at the Fort Collins, Colorado, and from the station WWVH, Hawaii. The following technical radio services give the constitutive system stated radio, standard radio frequency, standard audio frequency, standard time intervals, standard music pinch, time signals, radio propagation notice WWV only, geophysical alerts, universal time coordinated plasma UT corrections, UTC scale with automatic cyclic time with the interval U to first unit of time to the first base on the Earth, uniform rotations of the Earth rotation per cycle, the unit of time in the adjustable interval. To ensure reliable coverage of the United States and for the coverage of other parts of the world, radio station WWU and WWV are provided with the primary name of the radio frequency listen day 3. 1 transmission WWV and WWVH are interpreted in 5 minutes of each hour. The silent period begins 15 minutes past the hour of the station WWVH for the 45 minutes past the other for the station WWV. These silent periods are provided with a limited errors cover the frequency. The National Bureau of Standards time transmissions. 2 primary standard audio frequency tone for the 440 Hz to the 600 Hz for the broadcast of the WWVH carrier frequency. The absence of the message 5,000 tones in broadcast during message interval. The 440 Hz signal with the denote of the 1 hour mark standard musical pitch above the middle of the C. The 600 Hz tone provided the frequency standard with the check with the 60 Hz power line frequency. Standard time pulse marked with the interval 1 second that exhibit the 5 second with a 1,000 Hz tone with the WWV and 6 cycle with the 1,200 Hz tone WWVA for the marker pulse with the heard the clock tickets interval with the 1 minute marked at the 0.8 and 0.8 seconds 100 Hz tone with the WWV and 0.8 seconds and 1,200 Hz tone for the WWVH. Each hour is marked with the 8 seconds of the 1,500 Hz tone on both stations. Universal time coordinated with the now for the WWVH between 45 and 52.5 seconds of each minute. On the WWV between 52.5 and 60 seconds of each minute. Annunciation, radio propagation conditions, geophysical alert with the Northern Atlantic area of the broadcast of the station WWV and notice with the 18 minutes after each hour. For example, the short-term announcement, I state the radio propagation quality forecast normally unsettled and disturbed propagation format repeated phonetically in the numerical code to ensure clarity with the letter designated the NUW to signify the normal unsettled and disturbed respectively clarify with the radio propagation condition with the time of the broadcast. Digits 1 through 9 indicate the expected radio propagation conditions during the next 6 hours. Refer to table 3 of the code of interpretation. The National Bureau of Standards forecast based on the information obtained with the worldwide network of the geophysical and solar observation. Show the National Broadcast Standard radio propagation code whiskey disturbed, uniform, unsettled, normal, 1 useless, 2 very poor, 3 poor, 4 or poor to fair, 5 fair, 6 to fair to good, 7 good, 8 to very good, 8 to 9 excellent. Mechanical rotation vibration methods. There are many instances where you are very much concerned with the question of rotational vibratory speeds, nozzle rotational speed with the necessary for the output of the direct current of the generator with the following with the below minimum desired output, where the speed of the motor, such as the motor in the teletype radar antenna must be maintained and constant. There are many instruments that you can use for the purpose of the tuning force oscilloscopes, of the vibrating reed meter, for the electromechanical count, for the oscilloscope, the frequency count, for the 2 other devices which may be used for the usually may require employing accessory equipment. Alright, tuning fork method is generally used with the conjunction from the measurement of the rotational speed of the teletype rotor fast estimated mode, not limited to the application. However, you must remember the tuning fork can be used with only one frequency, the frequency of the vibration, which was manufactured, therefore cannot be used with a variable speed mode. But to use the tuning fork mode, direct source of the light that you apply when the point of it to be observed in the cave of the teletype rotor black and white segment. Target is painted on the outer circumference of the motor governor with the radial spoke with the flywheel could be usually equal. Permit the motor to reach or operational speed under the normal load conditions. Otherwise, the motor slows down considerably with the normal load. With the apply with the standard height, and the tuning fork again for the side of the hand, but set it into vibration with the tug with the slow slots in the plate with attached for the tines of the fork. The cork speed with the obtained with the segment of the target appear with the stationary with the segment sent to move backward apparently against the no motor rotational direction speed low with the segment to move to the speed that's too high. There is also possible the target segment will appear to jump back and forth with the disappear suddenly. So the erratic action often become with the governor malfunction. The correct speed of the adjustment is reached with the target appear for the stationary. The stroboscope method. The UV the stroboscope of the management with the rotation reciprocating mechanisms in the instrument. So the light with the stroboscope lamp will fall directly on the arts to be observed. If the part of the uniform symmetrically play with the identification mark with the chocolate grease and pencil with the portion to be observed, this is provided with a positive meaning of the identification because there's only one reference mark. If observed during the measurement, you can see with either the fundamental synchronization or multiple, therefore, has been obtained in approximate speed of the rotation is known with the stroboscope that may be set with the appropriate position prior to the actual measurement. The main frequency with the control determine the rate of the flashing light with the reference mark with a moving part will appear with the standstill with the calibrated scale of the stroboscope will show the speed directly in revolutions per minute. If you have no idea what the speed of the moving part is, the best part of the measurement part when proceed with the high frequency strobe can deliver. Flashing rate of the stroboscope can then be gradually reduced with a single stationary image. The reference mark that is obtained at the point of the fundamental synchronism of the correspond with the speed of the moving part. Do not continue to reduce flashing rate of the instrument method. The point with the valid reason for doing so. If you do, continue to reduce the stationary image of the will be observed. The stroboscope will indicate a submultiple true rotational speed measure. The error will be introduced. Stroboscope generally high and low range switch with the typical low range of the 60 to 630. 600 RPM with the upper range of the 3600 arms to 15,000 RPM with the slightly overlap with the range of the instrument. The reliable frequency cover the view with the limitation and with the flashlight flasher tube light. Stroboscope should always be operated with the flashing rate low as possible. The consistent with the rotation speed with the observer. It should be required that they operate the instrument for a long period of time. Use the submultiple fundamental synchronizing speed. The pattern will remain just as stationary as the tube light will greatly extend. The addition quality of the light is better with the low range than the upper end of the scale. Sometimes we'll encounter the rotating vibrating device. This is moving faster or slower than the measuring range of the stroboscope will accommodate. Although the such speeds can be measured, you must submultiply synchronizing points. There are two methods of measuring high speed. The first method is to obtain a single stationary image of the rotating subharmonic speed relationship to record the value of the A. To obtain a single stationary image of the next lower subharmonic speed relationship to record value B. Unknown speed then can be computed with the following formula. Unknown is equal to A times B over A minus B speed. For example, the reading is 4,000 RPMs. Reading at B for 3,500 RPM. The computation would be as follows: 4 times 10 to the third times 3.5 to 10 to the third, and this over the speed would over 4 times 10 to the third would equal 3.5 10 to the third, which gives you 14 times 10 to the 6 over 5 times 10 to the 28,000 RPMs. The second method you would evaluate A and B would become the progressively smaller. A reading is over the previous example. There's the easier computations of over the A reading is still 4,000 RPM. The other obtain another submultiple reading of the B, but to keep in mind with the rubber a number of times. Stationary single image was observed. Stationary single image was observed with different time, but the final B reading with the 2,000. The calculation would become as unknown speed is equal to n to the n with the base x of the a times a to the b over a minus b. Unknown would be 7x down to the 4 times 10 to the second times 2 times 10 to the second equal over 4 times 10 to the second time minus 2 times 10 to the second. Unknown would be 7x over the 8 times 10 to the 6 over 8 times 10 to the 6 over 2 times 10 to the third would give you 28,000 RPMs. If the speed is lower than the lowest range of the stroboscope with the multiple image of the observer, for example, assume the reliable reading of 900 RPMs with obtained with the two stationary images was observed. Dividing the RPM number of the image will give the unknown shaft shown as below. The unknown speed 900 over 2 will give you 450 RPMs. Warning: exercise caution with the use of the stroboscope illusions over the stop motion is very convincing. Could do not attempt to touch the moving equipment. Frequency counter method. Various frequency counters have an applicable electronic tachometer to obtain the accurate measurement of the high-speed rotating machinery. Tachometer pickup that may be used to produce the signal of the directly with the frequency counter with the tachometer pickup. The design generated with 1 cycle per revolution. Counter will indicate the revolutions per cycle of the pickup of the design to produce 60 signals per revolution. The counter will indicate the direct revolutions per minute. Audio frequency measurement. The audio frequency can be measured with a variety of non-electrical electronic devices. For example, the non-electrical measuring device with the vibrating reed meter with the move of the disc frequency meter. Both of these devices are discussed in Neets module 3. They use the primary to measure the frequency AC power with 60 Hz. However, the such instruments do not have wide frequency for the range of most common instruments available to measurement audio frequencies are oscilloscope with the frequency counters. Oscilloscope method. The frequency where the waveform can readily determine by the UV oscilloscope. The most common oscilloscope the measuring frequency with accomplished for the first measuring time duration waveform. The frequency is reciprocal to the frequency equal to 1 over the time. They may be easily computed in 324. So the 4 divisions at 200ths of the second time division switch of the 5 thousandths of the second division frequency 1 over the time. The 1 over the 0.2 will give you 50 hertz. And another common method to determine the frequency of the waveform using the Josias pattern method discussed in Neets module 19. Your frequency counter method of the oscilloscope can be used to compare the rectangular waveforms. The purpose of the measure of the frequency signal. The frequency counter shown in figure 325. The more useful for the purpose of fundamental measurement with the frequency account for the total number of the cycle within the count for the precise period of the result of the display of the exact digital reading. Audio frequency signals must be sufficient amplitude for the trigger with the counter auto manual switch. Provides two methods of frequency counter operation. For the one method, initiate with the count over the simultaneous with the initiation signal to be measured. With this method, the auto manual switch should be set with the manual position. Second method, assume that the signal measured have the operating some of the indefinite period of time they will continue to do after. So after the measurement has been taken on hand, only the signal required to make the frequency measurement is the method. The auto manual switch is set to the auto position. 325. Show the frequency counter radio frequency measurement. The radio frequency measurements are primarily made with the frequency counter. Most oscilloscopes are limited in approximately 100 megahertz of the frequency meter of the show of the Hewlett Packard 530 series are widely used with the lack of the accuracy of frequency counter. Frequency meters provided the invention of the frequency counter with the most frequency measurement above the audio frequency range were primarily with the frequency meters. Process involved with the heterodyne with the frequency measure for the calibrated output with the frequency meter with the zero with which measure for the frequency with the read with the red with the method to provide inaccurate with the big cone with the reading error. The frequency meters we know today are entirely different with the predecessors. Today frequency meters contain the waveguide coaxial lines coupled with the blue core, the wavelength of resonant cavity of the meter to adjust the cavity to assume with the resonant frequency, the signal being with the measure for the resonant power of the absorbed cavity produced the dip of the output power level with the range for the frequency meters output constant of the present frequencies are read directly from frequency meter dial with an accurate with the most approximately 2 tenths of the plus or minus percent of the frequency meters are capable of measuring frequency with the 1 to 100 gigahertz per exceeding frequency limitation average frequency counters. 329 show the frequency counter. Frequency counters in early 1950, the frequency counters were with a device. The frequency counter was developed with a device for the measured accurately indicate the frequency of the 10 megahertz of the present day with a counter that can accurately read frequencies as high as 40 gigahertz. In addition, with the direct frequency measurement indications on the type of the frequency counters are measured for the wave period, which inverse frequency of the ratio will compare with one frequency against another time interval with the time between the two events and the time between the two functions of the event. In addition, with the frequency counter will have the event of the indication similar to the measured frequency except for the manual and the electronic stop start and stop gate with the control of the time over the measurement is taken. Frequency counters are provided the scaling of the form of the digital output signal. The frequency counter represents the frequency related division of the input frequency. All above the functions have the useful application for the pulse for the time and periodic function with the total life of the digital application ratio comparing with the harmonic related signals. So you the trigger of the testing equipment, you with the conjunction with the frequency counter with the time interval capability, you with the measuring interval between the two poles, between the two set of the pulses, with a wide variety of frequency counter with you with the technical manual for specific frequencies counter should be consulted to determine the instrument's full capabilities. Frequency counter accuracy. All frequency counter measurements are measured with the one part with the 10 to the 8 of the accuracy of the frequency counters have the provision input with the external frequency stand with the extent of the accuracy of the frequency of the stand with the frequency cell check with the capabilities provided with determine the counting lighting curve with operating properly. Wave meters. Wave meters are calibrated with the resonant frequency used to measure frequency, although the accuracy of the wave meter is not high with the heterodyne frequency meter, the advantage of the being with a comparatively small but a simple that can be easily carried out. Any type of resonant circuitry may be with the wave meter applicable to the extent of the kind of the circuit and flow with during the frequency range with the meters and temp of the resonant circuit with the coils and capacitors used with the low frequency wave meters, portalized circuit, the adjustable transmission line section resonant cavity with a very high frequency microwave instruments. There are three basic kinds of the wave meters: absorption, reaction, transmission time. The absorption wave time wave meters coupled with resonant basic resonant circuit will be rectified with the meter with indicating the amount of the current that induced the wave meter. The type of the wave meter loosely coupled to the circuit to be measured with the resonant circuit with the wave meter, then adjusted to be used until the current meter with the show of the maximum deflection of the frequency of the circuit under the type of the determined with the calibrated out with the wave meter. In reaction type of determined the name of the fact that adjusted with the U of the marker reaction occur with the circuit being either, for example, the wave meter loosely coupled with the oscillator with the resonant circuit meter with adjusted with the interval of the resonant circuit. Resonance oscillator circuit frequency with the segment of the wave meter dial with the measure of the observing the output current of the oscillator resonant with the wave meter circuit with the takes and the energy of the oscillator coupled with the current to dip sharply the frequency of the oscillator then determine with the calibrated dial with the wave meter. Transmission wave meter with adjusted coupled with the inserted between the source of the radio frequency energy indicated with the energy transmitted with the indicator only with the wave meter assumed to the frequency of the source of the transmission wave meters are widely measuring microwave frequencies. Figure 327 shows the typical cavity wave meter illustrated. Input cavity plunger crystal rectifier input D capacitor resistor 1 resistor 2 meter positive negative grounded. Wave meter illustrated with the type of the typical commonly measured the microwave frequency of the device with resonance circuit with effect with a high quality inductor capacitor tank with the measuring frequency of the capacity is very become the means of the plunger mechanically connect with the macrometer of the mechanism of the movement of the plunger cavity. Reduce the cavity size of the creep with the resonant frequency conversely increases the size of the cavity measuring made with withdrawing with the plunger low with the resonant frequency with the microwave energy with the equipment under the test and fed into the wave meter throughout the two inputs, the A or D. A crystal rectifier with a detect with the rectifier with the signal with the rectified current that indicate with the current measurement meter M. The instrument can be with either the transmission type of the absorption type of the wave meter, one with the U with the transmission wave meter, unknown signal with the circle to mean with the input with when the cavity is tuned with the resonant frequency signal energy is coupled with the coupling loop with the B with the in cavity out with the loop C with the crystal rectifier wave with the rectifier indicate with the meter with the frequency with the resonant little or no current flow with the into the detector meter. Reading is small, but therefore the micrometer of the test with the plunger variable with the until the maximum meter reading is obtained with the micrometer with the calibration chart with the supply with the wave meter to determine the unknown frequency. When the unknown signal the relative with the work weak with the stuff with the signal with the collection and also with the wave meters the absorption type of the device with the connection is made with the instrument input with the D with the radio frequency with the loop with the C. Then acts of the injection loop with the cavity using the resonant frequency with the collection maximum energy with the absorb with the cavity the current indicated with the meter with the cavity is not tuned with the frequency with the collection high current but is indicated the current meter therefore the cavity is tuned with the minimum reading of the depth of the meter with the resonance frequency to determine the micrometer cell and calibration chart. The pedometer with the resistor one usually adjust the sensitivity of the meter with the front panel of the instrument with the jumper one with the radio jack with the provide with the observer with the video wave frame with the testing oscilloscope. Chapter 3 Summary.